We have water that flows over a dam. So the water flows over a dam. And the flow rate is Q. So the flow rate is Q, and that's flow rate per unit length. So that means that we will have to have a depth that is in towards the paper, or towards the screen in this case. So we have also a height, h, so the height with respect to the dam, the level of the water, b, which is going to be the depth, the width, acceleration of gravity, g, fluid density, fluid viscosity. And so we have to find out the pi numbers for this case. And the question is, what is the pi number for the dependent variable? So first of all, what is the pi variable? So it said here, assume that the flow rate per unit length along the dam depends on, so that means it is a function of, so the dependent variable, it is going to be Q. So we need to find Q that is going to be a function of, and now we have to list all the variables. So that's going to be H, B, G, rho, and mu. Okay, let's do our list here. So we have Q, we have H, we have B, we have G, we have rho, and we have mu. So how many variables do we have? We have 1, 2, 3, 4, 5, 6 variables. How many reference dimensions? So let's see. Flow rate, it is volumetric flow rate, it is going to be L square per time. H, it is length. B, it is length. Gravity, it is length per time square. Density, it is mass per unit volume. But let me do this in FLT to vary. So we are going to do this in FLT system. So that's going to be density, it is going to be force T square divided by L to the 4th. And viscosity, it is going to be F divided by L, force divided by L square, and multiplied by T. So the number of variables is 6, so K, it is equal to 6, and R, it is equal to 3. Okay, why? Because we have length, time, and force. So we have length, time, and force, so we have 3. So K minus R, it is equal to 3. So we are going to have 3 pi variables. Okay, this part should be straightforward for everyone. And so the question is, how do we find Q, the equivalent pi number for Q? Okay, so just do it on your own and go back to the video. Okay, so we can do it in 2 different ways. We have to select our repeating variables. So let's go back for a second here. What could be the repeating variables? So we need 3 very different variables. So if we look H and L, they are both more or less the same, so we could take just one of these. If we take B, it is going to be okay. And we can take another one with it has only T, and another one with F. So this one also has only L and T, doesn't have the force, so that's like a good one. And we can take either one of these 2. density of viscosity, because they both have the same thing. Let me choose viscosity, because no reason. You could choose density as well. Okay, so if we select b, g, and mu as repeated variables, so if we are looking for the term that is going to be associated to the dependent variables, so the first pi number, we have to multiply these terms by q. So we have b to the a, g to the b, mu to the c, multiplied by q, and that's going to be our first pi number, or in this case the pi number that we are looking for. So so let's start. So we are going to have L to the A, G, the units of G are L, T to the negative 2 to the B, multiplied by mu, the units of mu, which are F, L negative 2, T to the C, and multiplied by the dimensions of Q, which are L squared T to the negative 1. So we have to take the units, the dimensions of L, T, and F, they have to be 0. So we have for L, so we are going to have A plus B minus 2C plus 2 has to be equal to 0. For T, so let's look at the exponent. So we have minus 2B plus C minus 1 equal to 0. And F, so F, we have C we have only C, so we have that C, that should be column C equal to 0, because it's only in the third term. Okay, so given C equal from 0, so we can have that from our second equation. So we have that minus 2b minus 1 equal to 0. So we have that b has to be equal to minus 1/2. So C equal to 0. So was our previous results. So now we're replacing the one on top. So we have A plus B, so minus 1/2, minus 2 times C, which is 0, plus 2 equal to 0. From these three equations, so we can deduce the value for A, that is the one that is missing. So we can also have that A, it is equal to minus 3/2. So therefore we can write that pi 1, it is equal B to the F, G to the B, mu to the C multiplied by Q, so which is equal to B to the minus 3/2, G to the minus 1/2, and Q. So this is the final result. So if we look in this case, so our result, it is going to be B. Okay, we can also try a different approach to have the solution. So by inspection. So how do we do by inspection? So by inspection, so we start with Q because it's the one that is being asked. So Q, the dimensions of Q are L squared T to the minus 1. So we have L and time. So Q, we have L and time, so we have to multiply by any other with time and L. So, well, time or L, so we went to cancel, so we can use actually G. So with G we have T squared, so we'll have to divide by square root of G if we want to cancel the time. So we are going to divide by G to the 1/2 to cancel T. So then we have Q divided by square root of G, whose dimensions are so we have L squared T to the -1, so we are going to divide by G, so which is L T to the -2 square root. So time is going to be cancelled, so this is going to be cancelled with this, and so we have T squared minus 1/2, so that's going to be L to the 3/2. Okay, now we need to cancel L, so we use, so from here, so we start here, we use G, and then we need to cancel L, so we can use either B or H, so I'm going to use B so we can have a similar expression. So we need to actually divide, because the dimensions are L, so we need to divide by B to the 3/2 to cancel L. So we have Q divided by square root of G, and we are going to divide by B to the 3/2, and the units are, so we have L to the 3/2 that is coming from before, and so we divide by the dimensions of B, which are L to the 3/2, so then this is dimensionless, so we put everything together, so we have that pi 1 is equal to Q divided by G to the 1/2, B to the 3/2, otherwise we can put that in the denominator as P1 equal to Q B to the -3/2 G to the -1/2, which is the same result as before. Okay, so moving into different topic, but is very related, it is the correlation of experimental data. So once we have the pi variables, so probably we want to do the actual experiments, and so we need to find out what are the relationships, the mathematical equations of those. Okay, so that relationship, it is the function that we are going to find, the function, the mathematical function. Okay, so let's start with a problem with one pi number. So problem with one pi number. Okay, for example, we have that the drag force is a function of the diameter, the velocity, and the viscosity. So this is a situation is very high viscous flow. So the inertia is not going to be important. For example, imagine that we have a sphere, and this sphere is falling into a very viscous flow, like honey, for example. So these are the parameters that are going to be involved: the diameter, the viscosity, and the velocity, and of course the force. So our variables in this case are F, D, B, and mu. And so the dimensions of this are force, it is ml t square, diameter L, velocity L divided by time, and viscosity it is m divided by L divided by t. So we have 1, 2, 3, 4 variables. So k it is equal to 4 variables, and r it is going to be equal to 3. We have mass, L, length, and time. So the number of pi variables, k minus r, it is equal to 4 minus 3 equal to 1. So we have just one pi number. So how do we find this pi number? Okay, so let's start with f. So we have the dimensions of f are going to be m L over time square, and I'm going to do it by inspection. So to cancel mass, so I'm going to divide by mu. I'm going to divide by mu to cancel mass. So we have, let me move a little bit over here. So we have f divided by mu, it is going to be equal to ml t square divided by mu, it is m, and lt in the numerator. So mass is cancelled, so we have t square is going to be cancelled with this t, and L square. So the dimensions are L square over t. So now we need to cancel either L and t. So I'm going to cancel first t. So to cancel t, I have to divide by velocity. So divide by velocity to cancel t. So we have f, mu, and velocity. So the dimensions are L squared over t. And now I'm going to divide by velocity, and velocity it is L divided by t. So t goes in the numerator because we are dividing. So the t it is going to cancel, so the dimensions are L. So this is dimensions of. So now finally we have to cancel L. So let me continue here. So so we have to divide by d to cancel. Divide by d to cancel L. So we have f mu v d divided by divided by d. So the dimensions are going to be L over L, and so finally these two cancel, so we have a dimensionless number. So our pi number it is going to be equal to f divided by mu, velocity, and diameter. Okay, so what is the meaning of having just one pi number? So meaning that this pi number is a function of is not a function of anything. So because only one pi number, so that means that it's not a function of anything. If it's not a function of anything, that means that pi it is equal to a constant. So in other words, f divided by mu, velocity, diameter, it is equal to a constant. So we can solve for f. So the force is equal to a constant multiplied by mu, velocity, and diameter. So in this case, when we have only just one pi number, we can have actually a mathematical expression. So mathematical expression, what is telling us, it is that in this case we have the force, and the force is a function of mu vd, and the slope, it is a constant. That slope has to be found experimentally, of course.